Okay, so thank you again for your introduction. Today I will introduce you the PRISMA mission with a very brief overview of the capabilities of the hyperspectral observation. And I will mainly focus on the satellite and on the mission features. So, as you probably know, the PRISMA mission is an hyperspectral mission composed by a payload made by Leonardo in Italy and a platform made by OHB in Italy. We have a consortium of all Italian industries that build and tested the satellite. At the end, the satellite was launched on 2019 from French Guiana. The PRISMA mission is a technology demonstration which has the aim to deliver hyperspectral in vernier and SWIR channels with a panchromatic image. It has two modes, a primary mode that works on specific targets demanded by users, and a secondary mode that is a background mode to collect systematically images of the Earth. The PRISMA mission is composed by the classical three segments. We have the space segments with the satellite with the payload. It's a mono payload satellite. The launch segment was in charge of the Vega launcher, and the ground segment is always in Italy and divided between Fucino and Matera, where we have respectively the satellite control center and the mission control center. These are the main characteristics of the orbit. It is in a sun-synchronous orbit with a period of about 100 minutes and a lifetime of 5 years. The satellite mass is more or less around 800 kilos. This is the PRISMA satellite. As you can see, it is divided in three modules. We have the lower module, the upper module, and the payload module. The payload module has a large cover to protect the heat from the intense heat for the payload. The satellite stands normally in sun pointing, and when it has to point to a target, it moves in nadir pointing, and then it moves depending on the roll angle to acquire the target. So the PRISMA has an imaging spectrometer that goes from 400 nanometers to 2,500 nanometers. We have two channels, the vernier and SWIR channels, and the panchromatic camera. The resolution of PRISMA is 30 meters for the hyperspectral channels and 5 meters for the panchromatic channel. PRISMA is called in this way because the dispersing elements are based on prisms. Here you can see the optical layout of the payload and the actual payload during the testing. You can see that we have 4 very large and very accurate prisms on board. The PRISMA payload has these main features. I already talked about the resolution, the spectral range, and we have the SOC of less than 10 nanometers. the spectral width less than 10 nanometers. We have a very good signal to noise ratio and a very good absolute radiometric accuracy. We can have a compression of the data on board that is a lossless compression and a near lossless compression, but we mainly use the lossless compression with a factor of 1.6. This is the area of interest of PRISMA. As you can see, I think this is more and less. This is more or less, I think it's 70 degrees north and 70 degrees south. This is the area of interest, but the satellite is able to acquire up to 82 degrees north and 82 degrees south. This is the catalog. This is the main page of the catalog, and I think you will have a very deep information about that just after in this day. And this is just an image to show the near as we're in composite images and the panchromatic image. This is one site in Italy near Milan. I would just to briefly introduce you the pre-feasibility tool. This is a tool that we have made in these days, and it will be available to users probably at the end of this week. This is very useful because the user could have an estimation of the data take opportunity with the possibility to have multiple points or a single point. So this is this will be probably the user interface with the single point insertion. So you will have here the parameters that are the parameters of the PRISMA interface with a graphical information about the future tracks. And this is instead the possible insertion of data from a CSV file that could be related to multiple targets. And this is the output. This is what you will have, what you will see. Once you want to acquire on a target on Rome, you will see the start time, the stop time of your probable acquisition with the latitude and longitude and roll and the solar zenith angle. So you can evaluate what is the best data take opportunity for you, and maybe try to have some simultaneous acquisition with other sensors. And it is important for us to have a more little time interval for searching your target. And this is for each day we can produce 4 images of the tracks of each day. So this is today, September the 8th, and it's more or less 7:40 UTC. So the satellite will be, it's upper here, and in some minutes it will start to operate on this track. So this is a very useful information for users. Now we have the PRISMA second generation mission. We have started the selection for the main contractor, and now we can start with the contract that we start very soon. This is entirely funded by the ASI, the Italian Space Agency. And while the PRISMA, the current PRISMA mission is a pioneer for us for the hyperspectral observation, the increasing interest in this field forced us to move towards an applicative mission. So this will be very different from PRISMA mission regarding to the way the satellite works. We will mainly have a foreground acquisition with systematically acquisition, trying to acquire the same target always with the same geometry, with the aim of cover the entire world. This will mainly achieved by rolling the satellite between fixed angles, so we can ensure that each target is acquired at different times with the exact same geometry. One of the most important performance features that we will have on PRISMA second generation is the resolution of the hyperspectral products. We will have 10 meters of ground sample distance in a mode that we have called the spotlight mode. It's an high resolution mode that will have a very high signal noise ratio. This is comparable to the chime mission, but with a resolution of 10 meters. And this will be coupled with a panchromatic instrument with a resolution of 2.5 meters. The satellite will be very agile. It will be a very high productive satellite, and it will have the possibility of acquire mosaic images. There is a picture of a possible, this is the maximum possible mosaic for spotlight. So this is six squared images. Each image has a SWOT and length of 30 kilometers. Another point to be introduced for you, it's that the Italian Space Agency is working also with the several scientist groups in Italy, and we have closed, I think 6 months ago, what we call a research competition that we call PRISMA Science, and we have selected many scientists to work on PRISMA products. There is just a short list. I think there are just the first 4 winners. That just for page limits, I just limited to the first 4, and these are projects. All these projects have been started and regarded, and are about a lot of possible application that goes from air quality to water quality to soil properties, and there is a lot to land degradation, and there is a lot of interest in Italy for this kind of applications. And that's it. I have concluded my very brief presentation. If you have any questions, I'm very happy to reply.